So now we're delving into things that are, a bit more complicated, but still should be within the kind of realms of our common sense, right? So when we have two or more events occurring simultaneously, and these events are independent. What do we mean when we are saying that an event is independent? So an independent event means that the occurrence of one event has no impact or effect on the probability of the occurrence of another event happening. So, if we roll two dice at the same time, the value that the first dice comes up with, the event of the first dice, has no impact on the value of that second dice. I mean, unless they're magnetic, which is kind of a decent dice idea. Anyways, so they are independent of one another. So when we have this situation, we can use this handy-dandy special rule of multiplication to figure out the probability of both A and B happening. So the probability of A and B, when they are occurring simultaneously and they are independent, is going to be simply the probability of A multiplied by the probability of B. So again, we're going to do an example real quick so we understand what's going on. We were told that the AAA, American Automobile Association, surveyed its members, and they found that 60% made airline reservations last year. And so then we're told that two members are selected at random. What's the probability that they both made airline reservations last year? So since these are simultaneous events, right, we're looking at a period that is happening concurrently for both people. Both people are living the same year at the same time. And when one person makes an airline reservation, that is not going to impact another random person making an airline reservation. So we are going to be able to use this special rule of multiplication. And so the probability of the first person making an airline reservation, probability R1, is going to be equal to what? It's going to be equal to 60%, or 0.6, right? We're told 60% of the members made an airline reservation. So if we randomly select a member, we're going to, they're going to tell us at a 60% chance that they did make an airline reservation. We're going to multiply this by the probability of a second person. Since it's independent and it's occurring simultaneously, the second person is going to have that same probability. So we're going to multiply these two together, and we're going to end up with a probability that two random people sampled both made airline reservations at 36%. Questions on the special rule of multiplication?